ರೀ ಇದು 1 minute ರೀ.
Sir, we are just waiting for the director sir to join, and then we'll start the session, sir.
Done.
पुनीत सर, आप बता दीजिएगा जब डायरेक्टर से ज्वाइन कर लें.
वेलकम डायरेक्टर सर. मनीष सर, डायरेक्टर सर ने ज्वाइन कर ली.
ठीक है. Okay, so Good evening, one and all. And today we have one more lecture in our lecture series of National Space Day. And today we have Dr. Darukesha with us, and Director Sir of Mesra Jaipur campus has also joined. And we have Mr. Puneet Sharma also with us. He's Assistant Professor at Mesra. So before starting, I'll first introduce our Director Sir to everyone, and then we will get introduced with our guest for the day, and then we'll go ahead with the lecture. So Dr. Piyush Tiwari, he is right now Director of Mesra Jaipur campus. He has done his PhD and MSc from IIT Roorkee. He has also done PG Diploma in Industrial Management as well as PG Diploma in Computer Applications and System Analysis. His major research interests include ordinary and partial differential equations, mathematical modeling of geophysical systems, heat transfer, moving boundary problems, image segment, ear implant modeling, etc. He has around 40 publications in various reputed international and national journals and conferences. He also has an international innovation patent to his name. He is also member of editorial board of International Journal of Intelligence, Information Processing and Proceedings of the National Academy of Sciences, Physical Sciences. He is life member of Indian Science Congress. So we welcome you here, sir, and we would like to listen few words of motivation from you, sir. Sir, आप unmute कर लीजिए.
I would like to thank the organizers for this series and faculty member and you especially who are taking efforts and doing all the arrangements and timely. I am very happy that all the series are starting on dot and there is no delay. Last time also it was exactly on time. I would also like to thank Dr. Dhanuka basically for giving his time and hopefully very soon the Government of India initiative on these type of topics are going to be a big boost, and our students whosoever have joined here, they will be the part of it. Any such effort doesn't give you a direct, you can say, benefits, but this keeps, when you keep learning such things, then you one by one, step by step, you upgrade yourself, and then you can join. For computer science or electronics or electrical students basically, and those who work on CFD, computational fluid dynamics, you can actually work a lot in this area. I have been to ISRO because one of my friend is there. So with that, I think I have very serious inhibition that you can do a lot good in this field, and the initiative is really very, very good, and we can say that this is going to be fruitful to our whole team. Thank you.
Thank you, sir. And now we'll welcome Darukesha, sir. So the introduction itself holds a lot of things to motivate us all. So Dr. B.H.M. Darukesha, he hails from Vijayanagara district of Karnataka. He obtained his master's in physics and joined ISRO in 1998. Then he did his doctoral degree from Indian Institute of Sciences, Bengaluru. His main area of research was ionizing radiations with nanomaterials. Right now, he's serving as Associate Director and Chief Information Officer for ISRO. He has been invited by Space Research Center at AGH University of Krakow, Poland as a visiting professor for 1 year from September 2024, and he would join the international team of scientists working on the experiments that are to be done by the Polish astronaut on board the International Space Station. Dr. Darukesha is an expert in realizing the microwave modules that establish the communication between the satellites and the ground station. His work was instrumental in indigenizing these modules for Chandrayaan mission when no country offered the much required 5-watt amplifier. Darukesha sir developed the amplifier in-house. The data from Chandrayaan, Mangalyaan and Aditya and all such missions have been coming through these modules, and right now he is currently studying the interaction of gamma rays with nanomaterials. So we are really honored, sir, to have you here, and over to you, sir, to motivate the students. Thank you.
Thank you, Manish. Thanks to Director Sir. And yeah, you have been doing excellent motivation, dissemination, and making sure that the right students are guided on the right track. So I must compliment the entire team of organizers.
Thank you, sir.
I'm really happy to be part of this endeavor. My proposal is this. I would like to speak for about 20-25 minutes, leaving another 20-25 minutes for, say, question answers. So I will leave it to Manish. How do we take questions? Maybe through chat box or directly. So we will let him take a call on that.
Okay, sir.
So for about 20 minutes, what I wish to say is this. How did I join ISRO? It is basically, you can take it as a case study so that you can decide how you can join. What did I do, what I do at ISRO? Then where else you can join? That is where the crux of the topic is, ever-evolving opportunities in the realm of space. So that would be the major portion. And then why join ISRO, and then why join science? So beyond this, I would keep the session open for questions. Well, coming to the first question, how did I join? Basically, you would have heard from Manish how he joined, and yeah, that motivates. Like that gives a clear picture. Okay, one person joined like this, so it may not be applicable for everybody, but that gives a clear indication. Well, as Manish introduced, I did my MSc in physics. Then between MSc first year and second year, in Ahmedabad, the Physical Research Laboratory conducts summer research training programs. I was there in 1997. Then the comet Hyakutake arrived. So the task given to me was that whether this comet will reappear or it is a one-time visitor to the solar system. So I observed for about 7 days the tracks, and then that formed an ellipse. The theory says an ellipse with an eccentricity of, say, less than 0.9 clearly ensures that the comet it's a repeater like that. So that's what I found. And then when I presented this to my guide, he asked me what are my plans. Then he said, you seem to have a fair flair for science. Why don't you consider? Why don't you think of these things? Then he suggested what happens in science and all that. Motivated by that, so I started looking for advertisements where scientist posts are open. Fortunately, when I was writing my final year exam, I came across one advertisement from ISRO. I applied, interview went well, and then after 4 or 5 weeks, I got a letter stating that if I have completed my MSc Physics in first class, I can come and join. So this essentially, though it looks so simple, I wish to stress that this would require a lot of, say, background work for all of you. So those who are willing to join, possibly you should not limit to where you want to go. You should be open for all the opportunities. Opportunities will strike, and every opportunity we should make use. So maybe during the question answer session, I can elaborate on that. Then what do I do at ISRO? By now, I'm very sure you have understood how ISRO works. ISRO is essentially a space organization. By keeping mainly the satellites in the space, we are going to reap the benefits. To take the satellites into the space, we need launch vehicles, the parts of which are fabricated across the nation, and then they move to Sriharikota. The UR Rao Satellite Center in Bangalore is the place where all the Indian satellites are manufactured or assembled. After assembly, after testing, the satellite moves to Sriharikota. Now the work at Sriharikota is to assemble this rocket using the various parts that come and mount the satellite over that and launch it. During the launch and once the satellite is in place, the master control facility Hassan or the ISTRAC Bangalore, they will keep track of this satellite. And then if it is a communication satellite, we, the end users, can have its direct use, either Department of Telecommunication, or in case of DTH, we can directly use it. In case of remote sensing, the NRSC, National Remote Sensing Center at Hyderabad, receives that data and then it disseminates. So this is how the ISRO this is how ISRO functions. In this, I was posted to UR Satellite Center. To make a satellite, various parts are needed. To fabricate these parts, there are various divisions. One such division was hybrid microcircuits, where the electronic circuits were made. Like, for example, you take one integrated chip and then you mount it on a substrate, give the interconnection and connect it to the external world to make it useful. During those days, there were the microwave modules are needed, and these microwave modules were imported. So what are these microwave modules? So once we send the signal to the space, the antenna of the satellite will receive that. After having traveled this much distance, the strength would have come down. So until it has to, that signal has to reach the computer on sitting in the satellite. So its path is something like this: low noise amplifier, the mixer, demodulator, filters, analog to digital multiplier, and it will go. Now suppose the satellite wants to communicate something to us. Actually, it does keep telling what is its health, or what is the pressure, the temperature, and things like that. So this data, once that has reached the computer on over the satellite, it has to come to the antenna. So this path is digital to analog converter, multiplier, amplifiers, filters. So these modules, whatever I'm naming now, these will have to work at microwave frequencies, not the digital frequencies. So such modules are called microwave modules. They were all imported. So it took about 5 years for my boss, me, and 2 of my colleagues to make them in India. Since 2003, we launched satellite GSAT-3. Since then, all the microwave modules flown on Indian satellites have been fabricated in our lab. So when you join ISRO or any such organization, you will be put into some division like this. The division will have its own priorities. You may have to meet the target, and once you meet, your life will be involved in this type of improvisation, things like that. I'm very happy that my first assignment was Atmanirbhar Bharat, and I could do that. So down the line, there were several challenges and then several possibilities, so that we could accomplish. Now coming to the question, important question, how you can join ISRO. I know for many people, joining ISRO, becoming astronaut, doing astronomy has been a dream. It's basically a fiction. Then, right, ISRO entry points currently are like this: ITI, diploma, engineering, MTech, PhD, BSc, MSc. Considering the type of work that ISRO currently does, one can imagine that people who study physics, chemistry, mathematics, computer science, mechanical engineering, electronics engineering, electrical, so these are mostly much sought after. But what I suggest is, if you go to our ISRO website, there is a section careers. In this, about current opportunities. If you come here, so what you will see is, so at various departments, what are the, okay, I'll go one more step back and then career progression. So these are scientists, engineer cadre, BE, MTech, ME, MTech with first class. So doctors are needed, MBBS, then technical assistant, 10th standard. So this page, I'm sure you noticed how I scrolled to this. Come to isro.gov.in, choose careers, career progression. So if you come here, this takes to UR Rao Satellite Center page, wherein all the possibilities, nurse, lab technicians, radiographer, pharmacist, what all majority of the say jobs that are there in ISRO are listed here and how they can progress in their career. This much is explained. So now you might choose any one of these or multiple of them. You can proceed with those applications. Now, one thing is not all of us can get into ISRO. So, but we would like to work on space. So, how do we say get these opportunities coming towards our way? So, this is the crux of the today's talk. So, there are 4 ways in which we can contribute to Indian space program. First is to join ISRO as an employee. Second is to join private companies that help ISRO. So there are about 650 private firms that are helping ISRO. That's why ISRO staff strength also keeps coming down, whereas the private sector staff will go up. Then the third way is if you join university or if you are teaching in a first grade college, possibly you will come across the opportunities for conducting sponsored research. ISRO may not be able to do all that it wants to do by its own employees. So it's always better to take the help from the academicians by funding their projects, by sponsoring their projects, which are relevant for space applications. Fourth and very exciting, important aspect arena is the startup. Now, if you decide I have some idea and I know the idea works, and if you are not planning to say join as an employee somewhere, but to employ some people, this is the right thing. There are about 200 say startups that are already working in space within India. So we are going to have very exciting time. So within these startups, just say there are activities that are for upstream and downstream. Upstream is basically building the rockets, building satellites, the hardware part of it, or essentially the technology part of it. Then the downstream is how best we can utilize this data. Here, the most of the arena opportunities are there in the downstream, because in ISRO we build rockets, satellites, technology, all that. But how we can use it to the fullest extent is up to one's imagination. So one need not get limited to whatever is being done by ISRO. So it is a whole lot of things are possible. So these are the arena, these are the opportunities. So one aspect here I would like to mention is, though the space technology started in 1960s, so it was only one company, 1975, made a private company made an attempt to become a private launcher, but then it did not succeed much. Only after 2010, 12, so private people are giving a heavy competition to the national space agencies, where the national space agencies are sponsored by, say, they are all under the direct control of their respective governments. But now things are changing. Space is becoming a place where one can invest and hope for the returns. So this is how these are the avenues that are there. Only thing, how best I make myself eligible and how best I make use of these opportunities is up to us. The next last but one question that I would like to ask and then answer is this. So why we need to join ISRO? If you, I mean, I'm sure that you know, uh, by if everything goes correctly by 2025, one or two Indians will go to space. They go up to 450 kilometers altitude. They'll stay there for 1 or 2 or 3 days. They conduct the experiments and safely they return. Between 2028 and 2033, so we will be building Bharatiya Antariksha Station. By 2040, an Indian will land on moon and return. So when we speak of these things, should we continue to be spectator the way we enjoyed thoroughly the landing of Chandrayaan 3? No, this is where I wish and I insist that you should become a player in these things. You should become a person who makes these things happen, not just a person who is sitting in front of TV and doing these things. So for making these enabling things, I wish you can join ISRO or space program. But then, as I remarked earlier also, we cannot hope all of us can get into space. There are exciting opportunities in Indian science. For example, our Kaiga atomic plant has run continuously for 962 days and set a world record by itself. When the whole world was I mean, seeking the vaccines, if not one, Indians gave two vaccines. Then our missiles are at international demand now. We have a target of generating 100 gigawatts of solar energy, leading the way to the world. So definitely we are at the very exciting time when it comes to Indian space or Indian science. It is up to us to make a mark on these things and make things progress. Life is beautiful. Let us make it little more beautiful by our contribution. If that happens, we'll be very happy. We'll be very happy to see some of you joining ISRO, some of you joining Indian science, and let's contribute. If India can lead the world, it would be a great accomplishment for all of us. Friends, that's what I thought I would share with you. Now it's time for me to answer your questions wherever possible. I'll answer. If I don't know the answer, possibly I will pass it on to Manish ji, then he will pass it on to you. Over to Manish.
Okay, thank you, sir. So, बच्चों मैं अभी चैट को ऑन कर देता हूँ. You can write your queries in the chat box. So I have enabled the chat, and you can now send the messages in the chat. You can ask your questions there. Okay, sir. So we have the very first question. Purani is asking question, when India will be part of International Space Station? So this is the very first question.
Great, Purni. Yes, so I appreciate. It's a very important, good question. I appreciate you are, say, keeping yourself updated with what is happening. As you may be knowing, International Space Station is currently managed by NASA, Europe, then JAXA is a part of it, Japan Space Agency. Now there is some uncertainty with respect to how long it will go, because essentially this is an old technology, right? So some new space stations will have to come, the lighter space stations have to come. So when that happens, possibly when there is uncertainty about how long the International Space Station will run, so it would be meaningful to have our own space station. Now, why we had to start? We had to join International Space Station. Instead, let us make a station, Bharatiya Antariksha Station. Let others join. So let us lead the way. Why I am saying this is this. See, when Chandrayaan 1 was launched, 6 out of 11 instruments were from abroad. So what it means is, like us, there are other nations, other space agencies who wish to join hands and then make a mark of them. Essentially, this is nobody has unlimited resources. So what we do depends on where we came from, where we want to go, what are our national needs, how much resources we have. So with all this considering, maybe this International Space Station we may not join. Let us hope our Bharatiya Antariksha Station one day becomes an international space station. Thank you, Purna.
So we have so many questions now. So I'll try to pick one by one. The next question is from Nishchay, and he is asking, what should we expect from Artemis mission and what can be the ISRO's role in it?
Fine, Nishchay. So that's another interesting question. Yes, Artemis, as we know, is US-led international program to go back to the moon. US went to the moon in 1969. Till 1971-72, the missions were there, and then 12 people landed on moon and came back. When it was left, moon was left abandoned because people thought there's nothing interesting. Only when Chandrayaan-1 went and it discovered the hydroxyl molecule, everybody thought, okay, if OH is there, if H is there, mostly we might get water. So if water is there, that becomes an interesting and exciting place. In these 5 decades, a lot of things have changed. Now, this Artemis program is built with a motivation that, okay, we are going to get water. We might build a colony on the moon so that it becomes habitual. Then now the question is, the most exciting part of Artemis is this. Next year when it goes, there's a plan to send a rocket right into the cavity, one of the holes in which the ice is expected to be there. As we know, the southern pole of moon has not been exposed to the sun. It is possible that water is existing there in the ice form. So one rocket will go, it will penetrate to a depth of about 10-15 centimeters. It will discover what exactly is there. So further programs will depend on the outcome of these things. So that's where Artemis is very interesting program. India also is a signatory to it, and we must expect a lot of science to come. Thank you, Nishchay.
Okay, sir, the next question is from Fazle Rabi Mandal, and this one is for the cutting edge tech, because he wants to know the applications of quantum computing in space technology. And I think ISRO is also planning a few missions related to the quantum communication and QKD from the space.
That's right. That's correct, Manish. So Mandalji, yes, this is the next big thing in space. How fast we can do, how so much of encryption is possible with quantum. So much of buzz is there. It's a hard technology to master. As of now, all space agencies are struggling, which means all are interested. So let us hope India will join it soon. Essentially, this technology enables us for wider bandwidth with super encryption. So this is what is making it exciting. Thank you.
Yeah, it's like there is like no conditions for the security. It is all secure.
Yes.
Okay, so the next one is because just now you talked about our astronauts flying to in 2025 we have Gagan planned also, and one of our astronauts is flying to International Space Station. So that has generated some curiosity about becoming astronaut from ISRO. So the next question is how to be an ISRO astronaut. Sushant has asked this question.
Okay, great. Sushant, fine. Currently, this answer may not be very attractive or appealing to you, but let's not lose hope. The point is this. So far, the astronauts have been chosen from Indian Air Force for understandable reason that they know how to deal with this, higher speeds, the the gravity effects at these altitudes, they are better suited for this type of activity. Now, if you want to become astronaut, we must first become fighter pilots in Indian Air Force. Possibly, say in NASA in USA, there was a condition like 2,000 flying hours, 10,000 flying hours, like that. So you will also have to meet that criteria. With so much of stiff competition, you may have to get through. This is one. Is there a possibility that India or other space agencies will open this astronaut position for public? Answer is yes and no. Yes is yes, there is a thinking, it might come true. No, because there is nothing as on now. Hence, nothing has been on the rolls. So there might be a possibility that, okay, we might come across a possibility that we might become astronauts. So let us hope that either we join Air Force. When you are in Air Force, a call comes, an invitation comes from ISRO or other space agency or public space agency, so that you can compete and you can get selected. So let us also hope that ISRO will choose from the public where we are all eligible. We can give our candidature and do. The third point is, as you might have guessed by now, there are private people also can go to space. You don't have to be a pilot, but then you will have to pay as a passenger. So if you go as an astronaut, you're a sponsored person. Now there are 6 companies who are taking common people to the space. So Blue Origin is one of them. So that is shortest say trip that they can conduct, 3.5 minutes. You will reach the boundary of Karman line and come back. And currently the price is about 32 crore rupees per person. Let us not lose hope, because it seems the aeroplane tickets were also equally costly when they started. As more and more people we keep going, we would expect that the prices will come down. And interestingly, there is one hotel being built in space. By 2027, you can go there, stay for 2-3 days and come back. So things are going to be exciting. Currently, becoming astronaut is not, there is an element of luck. So let us hope luck is on our side.
Okay, sir. So next question is again related to quantum computers and space science. So I think that has already been answered. So we can move to the next one. Next question is from Mr. Azhar, and he wants to know about the expected date of NISAR mission. What is the expected date for the NISAR mission launch?
Okay. Asanji, yeah, it's already there in the public domain also. It was supposed to go in September, but then for extra precaution, NASA decided that the reflectors they would take back to California and then do the additional coating and bring it back. It will come soon. Then it would get ready in few months. But then this has array of reflectors to be deployed. So when this deployment happens, essentially it should not be cooled. So if we launch, say, in November, December, what happens is it goes into a period where the eclipse, it's a remote sensing satellite, it comes behind the Earth. Thereby the power generation is reduced for limited amount of time, and then we may not be able to keep it hot all the time. So to avoid this, the next possible thing is, as per the mission statistic, it's around February. So this is also in the public domain. There is nothing new here. So all going well, we might expect first quarter of 2025, NISAR will fly.
Okay, so the next question is from Saurav, and he is asking, sir, as a dropper, what should be my first priority? Focus only on JEE or learn? what I'm really interested in. Okay, sir, I think I'll address this question because I think this question is more related to JEE and preparation. So, Saurav, obviously, if you have some bigger dreams, let's say you want to join ISRO, then JEE is one of the way to join ISRO. You can appear for JEE main and then go for JEE advanced, and through JEE advanced, you can go to IIST. And after continuing there for 4 years and completing your degree there, you can become the ISRO scientist. So you will get to learn also, and you will get to appear in the exam also, and you will be get to make your dreams a reality. Now again, sir, we'll come back to the more relevant questions related to space. So Atisha has asked a question that is about how a biology student can join ISRO, sir.
Yes, this has been very frequently asked question. Yeah, as I was mentioning, considering the current activities of ISRO, we might see that physical sciences, chemical sciences, mathematics are dominating. Yes, biochemists, biologists might be required in near future, because once we build Antariksha station, once going to space and coming back becomes a routine. That is where experiments will have to be conducted. These experiments, it is better that they are of multidiscipline. So for example, so today what we can contemplate is this. Suppose I grow a crystal, say copper sulfate, putting in copper sulfate solution, we know it crystallizes. Then can this crystallization be uniformly good in the space? Suppose if I build in space. So this is one. Then coming to the biological aspect, it is said that the kidney stones that are formed are faster in space. So what does it mean? It means if I want to test a drug for kidney stone, its efficacy also can be quickly tested. So more of experiments are from biological side, because it has to be useful for human beings. So that we can justify repeated going back to space. So this is where biology students have got a bigger role, but whether they can play this role being inside ISRO, yes, but very limited. Outside, yes, unlimited. That much we can say. So biological students can aspire to work for Indian space program or any space program through this type of experiments.
Yeah, recently, sir, some astrobiology kind of new buzzword has come that there will be a new field of astrobiology. And then when we talk about our Bharatiya Antariksh Station, there will be many biological experiments and tests that will be conducted there regarding the growth and the drug discovery and all that thing. So huge scope is there, but just like, there is one point here. I like to tell our friend Atishai that you become good in your field. And then one day you will find that you are the one who will be ready to serve the country. The opportunity will come and then you will be ready. If you are waiting for the opportunity and then you will start training yourself, then you will be way behind in the race. So just start working, focusing on your discipline, and then it will be good when the opportunity comes. Then you will be picked. Just like when sir was saying, fighter pilots, when they are serving in the Air Force, and then when the requirement comes, they will be picked. No, okay, we'll move to the next question. And next question is from Pallab. Question is a bit controversial. So, sir, if you may, if you wish to answer, you may, and we can skip also. Why the budget is low?
Okay, okay, we can take this question.
Okay,
Yeah, budget. Okay, per se, we can say only low when we ask more, but government gives us less. It's not so. We have been known for frugal technologies. What we ask for, government has been providing. So it's not the question of low. So, and the question comes priorities. We are also Indian citizens, right? So how much we can do in 1 or 2 or 3 years for space program? For example, Gaganyaan, as you know, it is 10,000 crore say activity. So that being the case, when budget is needed for a specific program, it is allotted, it's given. Now the question is, to what extent we can plan for such ambitious things. So this depends on, again, what are our national priorities, where the amount has to go. So that way we are getting what we have been seeking. So there's nothing like less. Yeah.
Okay, sir. So the same student Pallav has asked one more question, and this is very interesting. He is asking why ISRO do not think about donation directly from the common Indian people.
Well, hello, thank you. In fact, this is also several times I received this question. Yes, people, there have been mails every day. I will donate 1 rupee, 10 rupee. You please tell your bank account number. Yeah, again, Pallav, in connection with the previous answer, what I would like to extend is there's no dearth of money here. We have been getting what we want. So possibly what I suggest is, if you think that you have a great idea, money crowding, pool funding will happen. You announce that you are going to do this. Sponsors will come and they approach you, they give you money, you make a company. This is how Agnikul, Skyroot, or say Digantara, or all these startups are working. Maybe you can think in that on becoming entrepreneur and collecting money and becoming another space agency like ISRO.
Okay, sir. So the next question is related to Indian Space Station, Bharatiya Antariksh Station, and it is like ISS is ending its operations in 2030. After that, the only space station will be the Chinese one. How will ISRO manage the Indian space station? I think Mohak is the student. I think there is some confusion. It seems students are thinking that we are dependent on International Space Station for our operations. I think there's some confusion.
Mohak, yeah, that seems to be a notion, but these space stations will work independently. They are, as we can see, International Space Station is about 200 feet long, 35 feet wide, about 30 feet tall tube, in which there are several segments. There are pressurized chambers, unpressurized chambers. There is service module and the experimental module. People will have to stay within this. So this is how it is built, and it is surrounding orbiting the Earth at about 400 to 450 kilometers orbit. This orbit is identified for human activities. So this is where it will be revolving. So the way we can launch a satellite and keep it orbiting, we can launch or build the space station and keep it orbiting. So there's nothing like if that is not there, what do we do? No, that's not the case. We can always go, approach, dock ourselves, exchange of material, exchange of people, and then it can come back. So that way it should be independent. Better it is independent of without any interference. We should be able to work.
And sir, I think ISRO is also planning the missions to demonstrate the technology also, like spacex, space docking experiment is being planned, and all these things are being done. And then recently I heard that we have also filed, ISRO has also filed a patent for that mechanism of docking. We have developed something very a newer kind of a version of docking mechanisms we have invented, and we have got it patented. So this means we are developing our own technologies, and we are going to implement our own technologies, indigenous technologies like ECLSS also, sir, that we are doing on our own. So I think we won't be dependent on anyone else, and we are also building the capacity of our launch vehicles. So everything is being planned and is being done in such a way, Mohak, that we will be doing Bharatiya Antariksh Station made in India by India. So don't worry, even if ISS is not there, then it will be a bigger opportunity for us.
Yes.
Fine. So, sir, the next question is from Abhideep Jain, and this is a question that is being asked to me also, sir, from many students from engineering side. The question is, how can I do, or how can I get to do a project under ISRO or other government organizations? Like students want to do project or training and workshops, how they can approach ISRO, how they can apply for that thing under ISRO.
Fine. I'll just go back to my screen wherein I can show. Say, Manish, is the screen visible or
Yes,
website visible?
yes, sir, visible.
So come here, engagements, internship and projects. So this page is dedicated for giving the information about the projects and things like that. So here are our various centers that offer the projects. URSC Bangalore, Space Application Center Ahmedabad. So all these. So these pages give information about how you can apply, where to apply, when to apply, things like that. But it also says that the seats are very minimum. Only, unfortunately, very few might get, because we are ISRO scientists are busy with ISRO projects. So we would like to definitely encourage a lot and lot, but given the project load at that point in time, this number may vary, but there are a good number of students who do projects in ISRO centers. So this, if you visit this page, all details will come up. Yeah.
Okay, sir, one more question, very relevant now, because we have talked about joining ISRO, and then you have talked about what are the different possibilities where we can enter into ISRO. Chanchal wants to know that, sir, one can join ISRO after doing MTech in space engineering. So I think here some little bit of a bit of information if you want to share again with the students, because
Sure.
this is specific for MTech.
Yeah, Chanchal, it's a good question. In fact, many of us also feel doing engineering in aerospace, aeronautics will gain upper hand or edge over other, say, branches. But say, let us think practically. How do you get into ISRO? Only after, say, applying for a job opportunity that appears here. So current opportunities. So if you read what all the opportunities that are there are listed here. So now the point is, there are several courses that are required. You will become eligible when you do mechanical engineering. Aeronautical engineering also gives you an eligibility to write. Now, the question is, you will have to take an exam, ICRB, ISRO Centralized Recruitment Board exam, a written test, followed by interview. So now, this is where you will have to compete. You will have to be really good, and you will have to be really fundamentally good. Now, the important question is, what is that we say which is fundamental? Let me make it very clear. The stuff that is there in 6th to 12th standard NCERT books, and last but 1 year of your degree. Suppose you are doing engineering, first, second, third year of degree is what we can say fundamental. So if we can master this, it would be a bit easier to, say, get through this ICRB. There are opportunities, but there is heavy competition. Now coming to the interview part. Essentially, the interview research aptitude is needed. So what do we mean by this research aptitude? It is to ask where the current law or current theorem stops. For example, Newton's laws of motion, are they universal? No, because once you start making an object moving with a velocity close to that of the light, Newton's laws are no more applicable. So this is where our students will have to keep thinking, okay, here is the theorem, here is the theory. So where it will apply, where it will not apply. Only when we know here it is not applicable, we get an opportunity to study about this, to improvise this. This is what we call research aptitude. So possibly this is not being taught in our academic courses as an approach, because we all our textbook we say Newton great and all these laws are fine, but then at the end of, at least we should be mentioning that these are applicable here. Here is an opportunity for you to make it further widened. So such things, once you know, the questions in interview will be of that type. So now what you study is, it should fall into one of the eligibility courses, one of the eligible courses for you to write. Aeronautical engineering is one of them. So that part is taken care. Now, cracking the written test and cracking the interview requires this additional skill. Hopefully you can do that, and we would like to see you in ISRO.
That was great, sir. So, sir, next question is from Mr. Ganesh, and he's asking what is the current status of development of ECLSS system, and the next question to this is also related to the Gaganyaan mission only. That's what is the status of Gaganyaan mission? That is from Ganesh, and another one is from Shubham.
Okay, Ganesh, ECLSS is one of the important aspects of Gaganyaan. It is being developed. Sometimes it so happens that some countries offer the help. In due course of time, we will realize our requirement is much stringent than what they can offer, or sometimes they back out. So it's always better to start from the scratch, and we should be self-reliant in these things. So understanding these things and making things one by one is currently going on in all aspects of human cavity, habitable enclosure. All aspects are being studied. So this is the current status. It will come out in public once we reach milestones. Then Ganesh, Shubham asked about Gaganyaan status. Gaganyaan is progressing well. You see, now we cannot afford to keep people and then keep trying. So without the astronauts, some certain tests have to be done. When do you think are the most challenging parts in any space mission? Is takeoff and landing. True with our aeroplane flying also. So we have to test all scenario what can happen. Now suppose there is a problem when the Gaganyaan vehicle is on the pad. So that is where pad abort test was conducted. What it does is, essentially it will pull out the crew module, service module, so that it throws into a safe zone. They will come back. Now what is the next stage? Next harshest position is when the rocket crosses a speed of that of sound. So that's the highest level of vibration, shock we can experience. So suppose there is problem with the vehicle, what it can do? So crew escape system will come into picture. Crew escape system is having another 4 rockets. They are very quickly deployable. The moment it receives there is a problem, the entire system will be pulled up. Now one rocket is going over that, the crew is there, that crew itself will go up. So this is what was done by in the recent crew escape system test. The rocket was flown to about 12 kilometers. Command was given. The crew escape system took it to another 5 kilometers safely away, and then it landed. Now the next test is what? Suppose when we are returning, we use 8 parachutes. So what if one parachute is not opening? What if 2 are not opening? And there is a sequence also. Like this has to open first, then bottom level. What if the first one opens first, bottom one opens first? So these combinations, permutations and combinations have to be tried. This is where integrated assembly testing, IADT, are being planned. So once we are comfortable, once we know, okay, we have crossed this hurdle also, we can go for the next level. So it is like walking in a forest. When you know you are walking on a road, you know there are milestones. next, your town is 20 kilometers away, 15 kilometers away, we can estimate. But when we are going in a forest, the territory is unknown. We had to go after crossing something, we will realize, oh, we should have taken the other path. Then we come back to the same path. So we will have to start. So this is how it has been very exciting. It has been challenging. So let us hope we complete all the tests quickly and have an Indian in space at the earliest.
And sir, one more question. I think we can take one or two more questions because then our time is getting, we are getting close to the ending time. So one question is, can ISRO make reusable rockets or even better ones? And when will this be possible?
Okay. Can ISRO make? Yes, definitely yes. Technically, it is possible. In the initial time of our discussion, today's meeting, that I was showing the website, the RLB coming was repeatedly, you would have seen. This happened in Chitradurga recently. Now, as we know how to go to space, how to come back from space is something that we are mastering. Now, instead of trying with the heaviest rocket itself, we will make a small scale model of that. That small scale model has to come and land on the runway. Now, instead of going into the space, we will use helicopter, take it to about 4.5 kilometers, 4 kilometers away from the runway, and you leave it. So with a velocity such that as if it is entering from the space. So that's called pillbox condition. Now, what our pushback, the winged machine does, it will search where is the runway. It will use the navigation, local navigation system, improved one. So it will come and land. It has so happened that runway is about 1.6 kilometers. So we have put a mark. Okay, its front wheel should come and land here. 4.5 kilometers is the distance. It has come as close as 4 centimeters. To that point, it has come. Now, we know we have gained expertise in this type of technology. Now we will go back to the real scale model and run similar things from the space, for which we need a much longer runway. The Sriharikota, there is one runway that is coming up. So once those experiments are also completed, yes, we can start using the reusable launch vehicles. And this aspect, it is not just limited to bring back and then using these things. There are countries which are thinking, okay, I'll place my strategic items in space. If you make your aircraft take off, radars will pick up. If it comes from space, that's the different aspect altogether. So there are companies that are thinking. There are different schools of thought in different countries. So this is why this technology is very useful, strategic. And yes, one day soon we will be having reusable launch vehicles. Yes.
So one more question related to launch vehicles only. Manjeet is asking, why is ISRO working on new rocket engine that can carry more payload than GSLV, PSLV, LVM3, M4? If it is being worked on, then please provide some information. Okay, I think he is asking, are we working on next generation launch vehicles?
Right. Yes. As you are aware, NGLV is our next level vehicle. It has to carry much higher load into the space. Interestingly, it is being built in collaboration with private companies, not just within ISRO. That's where you, as a researcher in an academic institution or a company that works for aerospace, will be useful. Yes, the answer is yes. ISRO is working for next generation launch vehicle. So definitely we need a vehicle that is much stronger and more efficient than LVM3 that we have. Yes.
Okay, yes, you have raised your hand. You can write your question in the chat box. We can take up your question also. In the meanwhile, sir, uh, right now, just now you answered about that our RVL, our Pushpak, landing like a space shuttle and as a space plane. So the question is, why is ISRO not going towards vertical landing?
uh, yes. Okay. I mean, there will be there are some thinking any technology like no, our Veda itself says no. Let the knowledge come from any direction. So we will be happy. Why not only say that type of vertical? Why not say oblique landing? So there are several things that are being thought. Uh, but currently, yes, because we have already invested, we have come to a good shape in RLV. RLV is given priority, but things would have already started in our say space launch vehicle design centers to think at these aspects. So it's not that we are not at all working on that. Anything, any new technology, any disruptive technology, yes, we had to catch up. Otherwise, we will be left behind.
Okay, so one more question is there that a new course has come, aerospace medicine. So I think avionic and aerospace medicine kind of a new course has come. Students are asking कि उसके बारे में बताइए. So I think Atishay, uh, this course has come up because everyone knows that we are taking big strides in space and the sector is booming and we have our own space policy in place and we are aiming to capture the market. So with a lot of focus on that particular segment, obviously such kind of courses have to come because we are planning to have our own Gagan Yatris in space in near future. So it's in line with the aspirations of the country. Fine, sir.
In fact, aerospace, Bangalore has this Institute of Aerospace Medicine. So it was limited to defense and research laboratories. Now that there are things like this, I received a proposal. We would like to build a hospital in space, and our hospital will come up when 300 people are there in space. So can you elaborate? So I mean, very interesting aspects are coming. So Institute of Aerospace Medicine, yes, definitely the specialized ones. But one word of advice or caution, what I can suggest is this: those who are still in high schools or say intermediate, when you are choosing your degree, try to choose something that is solid. That is, say, these degrees, specialized degrees are very good at the MTech and PhD level. The point is this: suppose I want to appoint a cook, uh, and you are very good at making jalebi. I can't eat jalebi every day, right? So it's always for me. I can say ask it to be purchased. So I will possibly appoint somebody who knows basics of cooking, from whom we can make new recipes. So that's how it works. So better choose a solid background course in the undergraduate and then specialize at the postgraduate or PhD level. Those who have already taken specialized courses at the degree level itself, please try to make the best use of it. And you might have to continue the same thing in MTech or something. That would be helpful.
Yes, sir. So just to add on to what Darukisha sir has suggested and advised, if you will keep your fundamentals strong, if you will keep your basic understanding of sciences strong, if you will focus more on the basic principles and you will get to the basic of that particular part which drives the whole science. I'm talking about physics, I'm talking about chemistry, I'm talking about mathematics, not just one single branch that has come out of it, then you will have better and bigger opportunities in future. And I can say that from my experience, you can see this from sir's experience. Sir has spent decades of time in ISRO and he has worked on different aspects of space technology. So when you are working on the basics, then it gives you a strong, the ground is strong, and then you are ready for the lift off. Because if your ground is not robust enough, your lift off will have some issues. So with this, thank you so much, sir. We took up many questions. This session was literally real kind of an interaction with the students, because we have taken up many questions in this session. In previous sessions, we were not able to take up so many questions. So thank you so much for providing more time for questions and discussion, and giving students the opportunity to interact with you. Thank you so much, sir.
Thank you, Manishji. Thank you. I really appreciate the kind of work that you are all doing. I wish you all the very best. Thank you so much.
Thank you, sir. Thank you, sir.
Bye.
Bye, sir.